In this part of the chapter, we're going to explore the structure and properties of ionic and covalent compounds. We'll even learn not only how to identify if a compound is ionic or covalent, but also how to name those compounds given the chemical formulas. So to define a compound is when two or more different elements combined. So two or more different atoms combine to form a chemical bond. And what a chemical bond is it's a form of attraction between any two atoms in the compound. Now, whenever we're talking about the formation of a chemical bond, we have electrons involved. And more specifically, the electrons that are involved are the valence electrons. So what does the term valence electron mean? Valence electrons are going to be those electrons in the outermost shell. So when we looked at the structure of an atom, we had the central nucleus of the atom where the protons and neutrons were, that dense center. And around that dense center, there were rings. And on these rings is where the electrons are located. So the valence electrons are going to be the electrons only in the outermost ring, the outermost shell. So it would be the electrons in the ring that's furthest away from that nucleus. So those are the electrons that are involved in bonding. Because they're further away from the center nucleus, they're held less tightly, and they're just more accessible. You can see in this diagram here, we have two atoms, each with a positively charged nucleus in the center, where the protons and neutrons are, and these two dashes, these represent the electrons, the valence electrons in their outer shell that are making a chemical bond. The two types of bonds we're going to talk about this chapter are ionic bonds and covalent bonds. So ionic bonds are when electrons are being transferred. And we looked at this in chapter 2. So when a neutral element either gains or loses an electron, you get an ion. So ionic bonds are results when the ions themselves are attracted to each other. For instance, if you have one element transferring or giving up an electron to another, what's going to happen is you're going to form a cation, a positively charged ion that has lost an electron, and an anion, which is a negatively charged ion that has gained an electron. So now you have a positive and a negative charge. And what we know of opposites charges is they attract. So ionic bonding is the transfer of electrons, and the resulting ions are now attracted to each other due to their opposite charges. Next, let's look at covalent bonding. So covalent bonding is not a transfer. This is when electrons are shared. We have two types of covalent bonding. We're going to look at nonpolar covalent and polar covalent. So what nonpolar covalent is when the atoms involved are sharing those electrons equally. For a polar covalent bond, this is when the atoms involved in the bond have an unequal sharing. What that means is one atom wants those electrons more. So they're not going to share them as much. This is going to result in one atom having a slightly positive charge, and the other atom, the atom that wants the electrons more, having a slightly negative charge. So let's first focus on ionic compounds, and we'll come back to covalent in a moment. So for ionic compounds, we said they're composed of ions. Ions being charged particles that form when an atom gains or loses an electron. Typically, this occurs between a metal and a nonmetal. If you'll remember from chapter 2, we saw when we were looking at ions that metals like to lose electrons, and so they form a cation, a positively charged ion. The nonmetals, on the right side of the periodic table, like to gain electrons. So if they gain electrons, they become negative, resulting in an anion. Well, since opposites attract, it would make sense that the cations and anions are attracted to each other, creating an ionic bond. So most often than not, we'll see metals and nonmetals forming ionic bonds. Now the bond is actually created due to the electrostatic forces between those positive and negative ions. In the example below, you can see the sodium atom, and all that is shown is the valence shell, the outermost shell. Notice there's just one electron in that shell. Well, that is due to the fact that sodium is an alkali metal, and all alkali metals have just one valence electron. So what happens is that sodium atom loses that one valence electron to another atom, in this case chlorine. The reason sodium wants to lose an atom is because it wants a full octet. So by getting rid of that one atom, it will now be in a noble gas state and be happy. Well, let's look at chlorine. So chlorine is the atom that's going to receive that electron from sodium. We're once again showing only the valence shell of the chlorine atom. You can see, if you count the electrons, that there are 7 green electrons in the valence shell. Now these 7 electrons, we can see from the periodic table that since chlorine is a halogen, all halogens have 7 valence electrons. Remember, everybody wants an octet. Everybody wants 8, just like the noble gases. And so when sodium loses that electron and gives it to chlorine, that completes chlorine's octet, and now you can see that chlorine has 8 electrons. So it has a full outer shell and it is now happy. Since chlorine gained an extra electron, it now has a -1 charge. Since sodium lost 1 electron, it now has a +1 charge. So these opposite charges are attracted to each other, creating an ionic bond. So a covalent compound is formed when elements share electrons. So there is no transfer of electrons here. Remember that covalent compounds are formed between 2 nonmetals or between a semimetal and a nonmetal. So in this case, there are no ions, no positive cations, no negative anions, but the 2 atoms involved just come close to each other, thus sharing their valence electrons in that outer shell. You can see in the diagrams off to the right are 2 examples of this. So in the bottom example, we have this blue atom sharing 2 blue valence electrons, and the red atom sharing 2 red valence electrons. So now we're going to look at formulas. So formulas are combinations of symbols giving the type and the number of atoms. Often going to refer to compounds as binary, sometimes tertiary, so on and so forth. So what binary compound means is when you have 2 different elements combined. So here are some examples of some formulas. In this first one, we have NaCl. So there are 2 elements present, sodium and chlorine. Now the subscripts present on these chemical formulas indicate the number of atoms. But notice for this first one, NaCl, there are no subscripts. So if you don't see a subscript, you can assume there's just one of each of those atoms. So this chemical formula tells me there's 1 sodium and 1 chlorine. Looking at the next example, we have CH4, once again a binary compound. This would be carbon and hydrogen together. We use the subscripts to figure out how many atoms of each element are present in the compound. So carbon doesn't have a subscript, so we know there's just 1 carbon. But after hydrogen, we see this subscript of 4. So that means there are 4 hydrogens for every 1 carbon in this compound. The last example has 3 elements now. We have carbon, hydrogen, and oxygen. Once again, to figure out how many of each, we're looking at the subscripts. So 5 carbons, 12 hydrogens, and 2 oxygens. So now let's look at covalent compounds. So we're going to learn how to name them. So a covalent compound is a nonmetal with a nonmetal. So notice my nice color-coded periodic table with the nonmetals being in yellow. Once in a while, we will see covalent compounds between a semimetal and a nonmetal. So just be aware of that. It's not always just nonmetals. That's just the most common type. When we find a covalent compound, it's when the electrons are shared. Sometimes they're shared equally, sometimes not so equally. Covalent compounds are also often referred to as molecules. So when you hear the term molecules, we're talking about covalent, not ionic compounds. So how do you figure out, based off the chemical formula, if a compound is covalent or not? Well, find the elements present in said compound and see where they are on the periodic table. So nitrogen, for instance. Nitrogen in yellow here is a nonmetal. It is combined with oxygen. Oxygen right next door to him, also a nonmetal. So now, since we know we have two nonmetals, we know it's covalent. So why is it important to know if a compound is covalent or ionic when you're trying to name it? Well, there's different rules for naming covalent compounds than there is for ionic. With covalent compounds, you start by naming the first element. So in the example we just saw, N2O5, you would start by writing nitrogen. Then you find the second element present and name that one as well. But the second element isn't going to be oxygen. We're going to add an ending to the second element present, and that ending is going to be an IDE ending. You can see off to the right here is a table of how most of the nonmetals change when an IDE is added. For instance, we're looking at this nitrogen-oxygen compound. So when we add an IDE to oxygen, it doesn't become oxygenide. It actually becomes oxide. Same with nitrogen. If we needed to add an IDE ending to that, if it was the second element present, it would become nitride, not nitrogenide. So just be aware of that. Next, we need to add prefixes to indicate how many atoms of each type are present. So this is where the subscripts are going to come in handy. Looking at the prefixes off to the right, I have them labeled 1 through 10. In this course, we won't see higher than 10 when we're actually naming a covalent compound anyway. So in the case of the example above, since there are two nitrogens, we would label that as dinitrogen. For the oxygen portion, since there are 5 of them, we would look at the prefix 5 and it would be called pentaoxide. So dinitrogen pentoxide. The correct name for that covalent compound. Now there are common names for a lot of the covalent compounds that we will be naming, but we're going to try to systematically name them. Let's try another example, CO2. Start by naming the first element. So C is carbon. Second step, name the second element, but add an IDE ending to it. So the second element is oxygen, so oxygen becomes oxide. Last but not least, we're going to add prefixes to each to indicate how many atoms. So carbon, there is no subscript after it, so we assume there's just one carbon atom. The subscript of 1 tells us it should be mono. For oxygen, there are 2, so in front of the oxide portion, we would write di. So we come up with monocarbon dioxide. Now, if you think about it, that doesn't quite sound right, because I'm sure many of you have heard of carbon dioxide, but never of monocarbon dioxide. So this is where we get our first exception. There's always exceptions to every rule. The exception is that the prefix can be dropped on the first element if there's just one, if it's mono. Okay, so what that means, if there's only one atom of the first element in that chemical formula, you do not put the prefix. You do always need the prefix on the second element, and you will need the prefix always on the first for numbers 2 on up. So next we're going to look at Cl2O7. So let's systematically go through it. Cl is chlorine, so that would be our first word, our first element. Second element, oxygen. Since it's a second element, we would change it to oxide. Next, add prefixes. 2 chlorines would be dichlorine. 7 oxygens would be heptaoxide. So dichlorine, heptaoxide. Now notice it looks a little weird having 2 vowels right next to each other. So another rule, and this is just a spelling error, which I won't ever count you off for because I'm not the best speller myself, but if you have 2 vowels next to each other, an A and an O, or an O and an O, it is just changed to O for the spelling purposes. It would just become heptaoxide. Now let's practice with some more examples. pH 3. Go ahead and pause if you want to try to come up with it on your own. I'm going to work through these kind of quickly. So pH 3, we have phosphorus and we have hydrogen. Hydrogen being the second element present, so it's going to become hydride. Next, we look at our prefixes. So you can see at the top here, we have the basic outline of how we name these. We have a prefix, the element name for the first atom present, and then prefix, and the second element has an IDE ending. So in this case, there's only 1 phosphorus, so you might start to say, oh, it's monophosphorus. But remember that rule. If there's only 1 of the first element present, you don't put the mono on it. So it's not going to be monophosphorus, it's just going to be phosphorus. The second element present, hydrogen, will be because there's 3 of them, hydride. The next example, so there are 2 nitrogens, so the prefix is going to be di-nitrogen. The second element present, oxygen, there are 3, so it would be tri, and then oxide for that IDE ending. Notice the IDE ending is only on the second element present. Another example, SCl6. So S is sulfur. How many? There's just 1. Since it's the first element present, we are not going to use the prefix mono. So it will be sulfur, and then chlorine becomes chloride. Since there are 6 of them, the prefix going on that one will be hexa, so hexachloride. Now let's look at writing formulas of covalent compounds. So given the chemical formula, like we just saw in the previous slide, you need to be able to name the compound. However, you also need to go reverse. What I mean by that is if you are given the name, you need to be able to write the corresponding chemical formula. So let's look at an example. If you were given the name dinitrogen tetroxide, how would you figure out what the chemical formula is? Well, you can use the element name portion, nitrogen, and oxide to figure out the elements involved. So nitrogen has the symbol N. So you would look it up on the periodic table and see what its symbol is. Oxide, that's just the IDE form of oxygen. And when you look up oxygen on the periodic table, its chemical symbol is an O. So now that we have the chemical symbols, we just need to put them together with the prefixes involved. So what the prefixes are going to tell us are how many atoms of that element are present in the chemical formula. The prefix of di in front of nitrogen tells me there are 2 nitrogens. The prefix tetra in front of oxide tells me there are 4 oxygens. So putting that together, we get N2O4.